Hello and welcome back. All right, so at this point, we should know about the product rule. We should know about the chain rule. Okay, so we're going to use those things together to derive the quotient rule. And the idea behind the quotient rule is, let's say we have a function that we call q of x for quotient. And it's going to have something on the top, some sort of numerator, and some sort of bottom denominator, right? If you don't like t and b, you can use n and d for numerator and denominator, but I think we all understand top and bottom as well. So what we can do, since we already have the product rule and the chain rule, is we can take this quotient and rewrite it like this. So we have t, the top, times the bottom to the -1 power. And so what we have here is a combination of a product of functions, and the bottom function is being raised to a power. So we're going to be using a combination of the product rule and the chain rule here. So if I want this derivative, dq dx, I'm going to handle it in this way. So the first thing that I notice, and the first thing that you should notice, is that we have a product here. We have the top multiplied by b to the -1. So we're going to have to use the product rule. Okay? And let me just write the product rule over here. And I want to abbreviate it a little bit. Okay, so this is going to be f g prime plus g f prime. Okay, so if I apply that here, the first function is the top function, so I'm going to leave it alone. Let me change my color back. Okay, so I'm going to have the top function, and then the derivative of this one. And this is actually the hardest part of this entire little exercise. So if the -1 were not here, we would just do b prime, but we have the -1. So the outermost function here is the -1 power. So we're actually going to use the chain rule. So first -1, and then b to the power -2. Then, okay, we handled the exponent, so now move inside. And so that's just going to be the derivative of b, which we can write as b prime. Okay, so that's the first part of the derivative, plus, and now we're going to leave the second function alone. In other words, we're going to leave this one alone. So we're going to have b to the -1, and then times the derivative of the first one. So that's just going to be t prime, or the top prime, or the derivative of the top. Okay, and now let's see what we can do from here. So we're going to have the top function times, and then let's see what this is going to be. This is going to be -1 over, using properties of exponents, b squared. So -1 over b squared, like that, and then times the derivative of b, and then plus, and I'm going to write this like this, t prime, the derivative of the top, over the bottom, because we have the property of exponent there, -1, so we're going to take it downstairs, and that exponent's going to become a +1. Okay, so let me just rewrite this in a little neater way. So this is going to be the negative of, we have multiplication here, so this is going to be t, and then the derivative of b over b squared, plus the derivative of t over b. And from here on out, I'm going to suppress the input. In other words, I'm going to get rid of the x. I'm just going to abbreviate using t and b. So here's what I'm saying. This is the same thing as the following. Negative of the top times the bottom derivative over b with no derivative squared plus the derivative of the top over the bottom. Okay, so now we essentially just have two fractions with different denominators being added. So we're going to need our least common denominator, which is just going to be b squared. Okay, so now the first term won't change one bit. And now the second term is missing a factor of b. Okay, so I'm going to multiply the top and bottom by b, but b times b is b squared. Okay, now the next thing I want to do is I'm just going to make the positive term, I'm going to write the positive term first. Okay, so I'm just going to write t prime b over b squared minus t b prime over b squared. And now our denominators are the same, so we can combine the numerators in the following way. T prime b minus t b prime over b squared. And the last thing I'm going to do, just to make this thing a little bit easier to remember, is t prime and b are being multiplied. Order of multiplication doesn't matter. So I'm going to do b t prime minus t b prime over b squared. And this is the quotient rule. This is q prime, and again we can also write it like this, dq dx. Okay, so here's the result. Okay, and you know the way that I like to just remember it is it's bottom derivative of the top minus top derivative of the bottom over the bottom squared. Yes, order doesn't matter, right? Because if we swap these out, we'll get the negative of the correct result, and you know, that's not what we want. So that is the quotient rule. Okay, let me do one simple example of the quotient rule, and then we'll call this video. So let's say we have this function. Okay, so you know, we already did the derivation. We just derived it, so I'm just going to use this result. Okay, so there's four things here, right? There's the top, there's the bottom, and then there's both derivatives. So I'm just going to, you know, I'm just going to write it down. My top function is 2x minus 3. The derivative of the top function is just going to be 2. My bottom function is sine of x, and the derivative of the bottom is just going to be cosine x. Now I have every piece that I need, so I'm just going to plug it into the quotient rule formula that we just derived. Okay, so in other words, f prime of x is going to be bottom derivative of the top. So bottom is sine x, derivative of the top 2 minus the top 2x minus 3, derivative of the bottom, and all of that over the bottom with no derivative squared, so over sine squared. And we clean up if we can. I'm not really seeing a whole lot we can do. 2 sine x minus 2x minus 3 times cosine over sine squared. Yeah, not really anything we can do there. But that's it. That's a simple example of the quotient rule and its derivation. Okay, so I'm going to call this video. Next video we'll do some examples.